When you solve systems by using substitution, you do not have to do any sort of graphing, and I know that's a big relief to a lot of people. The best way that I can think to describe the way that we use substitution is the way that a basketball coach substitutes in one of his players to a game. When a coach removes someone from the court, another player from the bench will sub in to replace the first. And this player needs to know what he's doing, and he's got to be basically almost the exact same as the player that he's replacing. And it's the same way in our math equations. If we remove one variable from an equation, we must sub in another value for that variable in its place. And that variable that is subbed in must be exactly the same as the one that we've taken out. So that being said, let's look at our first example problem. We have a system of equations here. Our first equation is y equals 4x minus 8. The next one is y equals 2x plus 10. We have graphed these in the past, but hopefully this method of substitution will let us go a little bit quicker once we get the hang of it. What I'm going to do is first look for a variable that is by itself, and in both of these equations I have a y that is by itself. It's already isolated. And what I'm going to do is sub in one value of y. My top value of y has a value of 4x minus 8. That is going to replace the y in the second equation. So I'm subbing it in. And we're going to rewrite that equation because our ultimate goal is to get an equation that only has one variable. So if I replace this y with 4x minus 8, and then I finish it out with 2x plus 10, I now have an equation that only has x. And we're ready to solve this. So we move our 2x to the left by subtracting. Our 2x's will disappear, and we will have 2x minus 8 is equal to 10. To finish it, we're going to add 8. My 8's on the left will cancel, and we have 2x is equal to 18. When you divide both sides by 2, x will equal 9. So I have an x value, but just as we learned from graphing these solutions, we know that we have to have an x coordinate and a y coordinate. So the next thing I'm going to do is take our x value, and I'm going to choose one of these original equations to plug it back into. And the good news is that you get to make that choice. It doesn't matter if you choose the first or the second. You just choose the one to you that looks easiest. So I think what I will do is I'm going to choose the second one to plug in my x. This time I do want to keep y there, and I'm going to be subbing in for x and replacing x with the answer I just found, 9. 2 times 9 is 18. 18 plus 10 is 28. So I have an x value, I have a y value, and now what we're going to do is put this in a coordinate form. We will have 9, 28. And what this answer means, this is telling me exactly where these two lines are intersecting. So if we were to graph these two lines, we would see that they'd intersected at the point 9, 28. So this is a one solution type of system. For our next example, we're going to see what happens when we don't have both variables by themselves. So in this case, I see that I do have a y by itself in the top equation, but in the bottom equation, y is not by itself. But this process of substitution still works. I'm going to look for the y that's by itself and substitute that value into the y that is not by itself. So we rewrite our equation. The bottom equation will be 7x minus, and instead of writing y, we're going to plug in our first y's value of 2x and then finish writing that equation. So my second equation has turned into this one with a subbed in value for y. And now we solve. 7x minus 2x is 5x. And when you divide both sides by 5, x is equal to 3. So I have one of my coordinates. Now I have to get the other one. And this time I'm going to substitute my x value in for a y. And once again, I get to choose the equation that looks to be the easiest, and to me, that's going to be this top one. We could probably even do that one in our head. Instead of writing an x, I sub in the value of the 3. And 2 times 3 is 6. So my y value is 6, my x value is 3, and that tells me where these two lines are intersecting on a graph at the point 3, 6. So I have another one solution system. Just like with graphing, it is possible to have a no solution and infinitely many solutions as our answers as well. So if we look at example 3, we'll see what happens when we substitute and what those will look like, because we won't have a graph to consider. For example 3, these two y values are by themselves, so let's pick one. Let's take this y value and plug it into the bottom y value and rewrite this equation. So we will, instead of writing this y, we're going to write the negative 2x plus 1. And then our equal sign, and then after this y here we had negative 2x minus 3. Alright, let's start by getting our x values on the same side. So I will add this 2x and add it over here. So that's going to cross out. Over here, this is going to cross out. And we will have 1 equals negative 3. Now anyone can see that this is obviously not true. 1 does not equal negative 3. And since that does not look right, and this is not a true statement, this is what we call a no solution. We could also see by looking at our equations here that we have a slope of negative 2 for both of them. Their y-intercepts are also different, so we can see just by looking at these lines that these lines are parallel. And if you'll recall from our graphing lesson, parallel lines also mean no solution. In example 4, we have something that's a little bit different. We only have one y value that's by itself, so let's take that value and plug it into this y and rewrite this equation. So the bottom equation is going to turn into negative 12x plus 4, and I'm going to write some parentheses here so I can fit the entire first value inside. And then I've got my equals 16. So my second equation has turned into the equation in blue, and now we're going to solve. I first start by distributing that 4. So we'll have 12x plus 16 after we distribute. And when I combine like terms here, negative 12 plus 12 ends up turning into 0, which essentially cancels itself out, and we have 16 equals 16. I can see that 16 is obviously, there we go, now that makes more sense. I can see that 16 is equal to 16, and since that is a true statement, that means that we have an infinitely many solutions problem. I can't spell. Here we go. If we were to graph these two lines, they would end up being on top of each other. So they would be the same exact line. And as we learned in our graphing video, the same exact line is in infinitely many solutions. This will conclude our video on substitution. Have a great day.